Okay, this is the back of L6.6. I'll do 2 examples here, and then you're on your own for the rest. So we have our same supplies that we need. I'm going to start with drawing the Lewis structure. So the first step, how many valence electrons does it have, and how many bonds does each need? I see a carbon here, and so actually two carbons. Carbon has 4 valence electrons and needs 4 bonds. So 4 and 4, valence electrons and bonds. And then H, we know, has 1 valence electron and needs 1 bond. That's our unusual one, so keep that in mind. Then put the atom or atoms that need more bonds in the center, and then connect with a single bond first. So I'd see 2 carbons here, and so I know they both need 4 bonds, and there's only 2 hydrogens to help out with the bonds they need. So I better put the 2 carbons together in the center, and then I'm going to put a H on each side. Because if I put 2 H's on one side, the other one won't be able to get the bonds that it needs. All right, the next step. Add double or triple bonds where needed to make the right number of bonds. See the bond chart. So the bond chart tells me that hydrogen is good. It has what it needs, because this hydrogen has 1 bond on it, and that's all it needs. So I cannot add any bonds here, and I can't here either. But carbon needs 4 bonds. So you have to kind of puzzle it out and say, well, how am I going to get 4 bonds for this carbon and 4 bonds for this carbon if I can't add any out here? So if you want to look at the bond chart, you can see one way to get 4 is to have a single and a triple. Since this is a single, I can make this a triple. So that's my 1, 2, 3, 4 for this carbon. And then these, because they're shared, for this carbon, we count them again. 1, 2, 3, 4 bonds for that carbon. Next, I want to double check how many valence electrons do they have and add unshared pairs as needed. Maybe you're starting to realize that carbon never has any unshared pairs. I don't see any dots here, and neither does hydrogen. But let's see why. Remember, on the last video I said if the valence electrons and the bonds are the same number, that means all the valence electrons are being shared in the bonds. 1 valence electron for each bond, and so none are unshared. And the hydrogen only has 1, but it needs 1 bond, and so again it's sharing that one in the bond. Every time they make a bond, they kind of like have to spend a valence electron. So they're all being shared in the bonds right now, so no dots. Next step for our lab is to make the 3D sketch, but we have to build it before we try to sketch it. Because if you draw this right now, maybe you'll draw it in a straight line, and maybe it is a straight line, but maybe not. So let's build it. So I need 2 carbons, which are the black ones, and 2 white ones, and for the H's, and then I need the single bonds, which are the short plastic things, and I'm going to need 3 of the long ones to make the triple bonds. All right, so I'm going to put all this together kind of quickly, just because I know these videos get a little long. So I'm putting 1 H on each of the carbons first, and then I'm going to connect them. Now here's where, if you don't build it completely, it kind of looks bent, but that's sort of like, what if there were some unshared pairs around those carbons, but they're not. So let's connect with the double bond, and now look at this one. Last one, I'm going to connect with the triple bond, and look what happens, because now there aren't any unshared pairs around. To get as far apart as possible, this area of electrons is pushing this over 180 degrees, and also this one. So you see there's no unshared pairs around the carbons, and so to get as far apart, the areas of electrons, or the groups of electrons, are going in a straight line like this. So now I'm going to sketch it. And when I look at my sheet, there isn't one that's got 4, but this is in a straight line, all 4 of them, so I would call this linear. So these are just the simplest shapes, and as we get bigger molecules, sometimes they kind of connect like more and more pieces. So keep that in mind. All right, if you want to stop and try the rest on your own, you can. Otherwise, I'm going to jump down to this one, and we'll do that one, and then that's it. So step 1 for the Lewis structures is to write how many valence electrons it has and how many bonds it needs. So valence electrons at the top, bonds at the bottom. Hydrogen is 1 and 1. Carbon is 4 and 4. And oxygen is 6 and 2. Did that pretty fast, but hopefully you saw that. So now I'm going to do the next step. Put the atom that needs more bonds in the center and use single bonds to connect first. So the one that needs the most bonds here is a carbon. And then I know the O also needs 2 bonds. So I have to think about now the H's. You might think, let's put an H on each side, but remember carbon needs 4 bonds. So we have to kind of think ahead and think, are we going to be able to give the carbon 4 bonds if I put an H over here? And I probably wouldn't, because remember, once I put another bond on the O, it already has what it needs. So in this case, I can't do that. I can't just put them evenly. So instead, H there, another H here, and there's my 2 H's, my carbon and my oxygen. Now it says add double and triple bonds where needed to make the right number of bonds. See the bond chart. So when I look at the H, those have the right number of bonds, and so I cannot add any double bond here or here. Carbon has 3 bonds in my picture, but I see that it needs 4. It either needs 4 singles, or it could do single, single, double, and I have a single, single, single here. Can I do a 4th single? No, because I don't have any more atoms to bond to. But let's look at oxygen. It needs 2 bonds, and it only has 1 right now. So that helps me to think about how can they both get 1 more bond? Well, they can do a double. Now everything has what it needs. 1 for the hydrogens, 1, 2, 3, 4 for the carbon, single, single, double, and oxygen has double. Last step, how many valence electrons do they have? Add unshared pairs as needed. Remember, if they're equal, valence electron and bonds, then we don't have any dots, and we also see that on our bond chart. Carbon, they're equal, valence electrons and bonds. All the valence electrons are in the bonds being shared right now. So no dots on carbon. This is the one single, single, double. Oxygen, though, they're not equal. 6 valence electrons, and only 2 are shared in the bonds. So we have to show the remaining 4, which is why I see that on my picture here. There's my Lewis structure. Now I'm going to build it. I've got a double bond here, so I'm going to use the long ones. The carbon and the oxygen are connected with the double bond, and then the hydrogens are on the carbon with the single bond. I'm going to show you this first. If I don't do a double bond for the carbon, it kind of looks like the pyramidal, trigonal pyramidal. There's 3 around the outside, 3 atoms around, and it's taller in the middle. But that's because it's sort of like there's an unshared pair here right now, but really there's a double bond. So this is why you got to make sure to build them correctly. And then when I look at it this way, it's planar, they're flat. Don't worry about the bonds curving, but the atoms themselves are all on the same plane. So this is 3 around, and 3 areas of electrons, or 3 groups of electrons. 3 atoms around, 3 groups of electrons. So this is trigonal planar. Planar means flat. Guess I kind of got ahead of myself, so I'm going to draw it. And then it's trigonal planar. All right. Good luck with the rest of it. If you want to use the key to self-correct a little bit, you can. The key is up in the front of the room. Good luck.